Module 7, Problem Set 1. Here we're asked what mass in grams of iron 3 oxide contains 4.55 millimoles of compound. All right, let's talk through the algorithm we'll use here. Knowing the name, we'll come up with the chemical formula. From that formula, we can determine the molar mass for the compound. We'll then take what it was we were given in millimoles, convert to moles. Then we'll use that molar mass to convert from moles to mass. Our factor label system will tell us when do we multiply, when do we divide. Okay, first, what is that chemical formula? This is an ionic compound, and the component ions are Fe3+. Oxygen is in group 6A. As the anion, it carries a -2 charge. To make the net neutral compound from these component parts, I have Fe2O3. And if I went through, used the periodic table to come up with the molar mass for that compound, I'm going to get 159.687 grams per mole. Okay, so let's start with what it is we know. 4.55 millimoles of the compound. Okay, we want our millimoles to cancel, to be left with moles. 1,000 millimoles in a mole. I want moles to cancel. I want to be left with grams. That molar mass was 159.687 grams per mole. I do this prescribed arithmetic. We'll see that the units millimole canceled millimole, mole canceled mole. I started with 3 significant figures. I'll keep 3 in my final result, and that final result is 0.727 grams. Let's try another one. Here we're asked how many nitrogen atoms are in 3.5 times 10 to the minus 4 moles of magnesium nitrite. Okay, again, in talking through the algorithm, we're starting with moles of compound. We'll use the chemical formula to go from moles of compound to moles of just nitrogen. From moles of nitrogen, we'll go to number of nitrogen atoms using Avogadro's constant. Okay, so again, we'll start with what it is we know. 3.5 times 10 to the minus 4 moles of magnesium nitrite. Okay, we want moles of magnesium nitrite to cancel. And we're going from moles of magnesium nitrite to moles of nitrogen. Okay, from that chemical formula, in 1 mole of magnesium nitrite, I have 2 moles of nitrogen. So the chemical formula itself gave me that conversion factor. From moles of anything, I can go to number of anything using Avogadro's constant. Recall it has inverse mole units, 6.022 times 10 to the 23 nitrogen atoms per mole of nitrogen. Moles of compound canceled moles of compound, moles of nitrogen canceled moles of nitrogen. I'm left with number of nitrogen atoms. 2 significant figures in that final result, 4.2 times 10 to the 20 nitrogen atoms.